Okay, so for this question, we're doing a chi-squared test of independence, or a two-way table, and it's at a 5% significance level. So the first part is to state the null hypothesis. And the main word here is making sure we use the word independent so they don't impact each other. So the salad meals per week. So salad meals per week are independent. And that's the key word. You need to use that word independent whenever you're writing about the null hypothesis, and it would be dependent for the alternative. So are independent of the position. And then I need to calculate the p-value for the test. So for this, I need my calculator, my GDC. And I'm going to go to second function matrix. And I'm going to go across here to edit. And I need to type my data in, which I already have. So this is everything that I then need. Then I can go into statistic and tests. And I'm looking for a chi-squared two-way table. So it's chi-squared test. It is not the goodness of fit. So chi-squared test. And my observed data is in A. That's matrix A. That's what the square brackets mean. The expected, it's going to put it into B if I need it. And then I'm going to calculate the information. So the p-value here is 0.0201 to 3 significant figures. And the last part is to state whether or not we should accept or decline the null hypothesis. And if I was to graph this and look what it might look like, I've got my chi-squared test, and we're interested in a 5% significance level. The value that I've got is, this is kind of like 2.01%. So I'm looking at a much smaller region, 2.01%. So that is on the right-hand side of the graph, which is the alternative, okay? If it was this side of the 5% value, then I would be interested in the null. So this tells me that I am rejecting the null hypothesis and I am accepting the alternative hypothesis, which means that the number of salad meals people have is dependent on the position that they're in the university.